Okay, welcome back to COSC 1436. I wanted to take a few minutes to share with you some information about the input, processing, output, creating an algorithm, and then also creating a test table, because you'll be doing this for several of your assignments. So this is chapter 3 exercise, and in this exercise, you're asked for the user to enter 5 test grades, and then you average the test grade and you display the average as a percentage. So when we talk about the algorithm, one way that you can look at it is in something called an IPO chart, which is an input processing output chart. And when you create this chart, you always think of the output in mind first. And the reason that we do that is, for example, like if you're building a brand new kitchen, the user of that kitchen is not thinking about all the details about the plumbing and the electrical. They're thinking about the end, what are the cabinets going to look like? Just here's what I want my kitchen to look like. So they think of the output of the very end. And that's what we think of programs. Like what is a user want at the very end? And then we work backwards and then think, okay, if that's what they want at the end, what will the inputs be? And what will my processing be? So in this particular program, the output is going to be what in your problem, what it says to display, or to maybe what to print to a file for our different problems. So here we want to display the average of the grades in floating point format with 2 numbers after the decimal. And we also want to display the average as a percentage, like 89.8%. So for the output, all we want to type in here is just words. These are just words in English. This is not code. So you're just going to write, we want to output the average of 5 test grades and the average as a percent. Okay. Let me take that out. So if I want to find out the average of 5 test grades, then my input has to be the, oops, no color, okay. Input 5 test grades. So very simple. This is a very simple program. And then processing is, how do I go from getting 5 test grade to getting an average? So processing is going to always be your calculations. And in this program, we just have one calculation. Well, you can break it out into 2. You can find the sum of the 5 grades and then divide by 5, or you can find the sum and divide by 5 altogether. So I'm just going to do it all together because we don't need 2 steps. It doesn't ask us to print the sum. So we don't need to find the sum. We're just going to add 5 test grades and divide by 5. This is a very, very, very simple IPO chart. As your programs grow, then your IPO charts become larger. Then your test table is always going to have your inputs and your outputs. So this is the inputs, right? 5 test grades. And in here, you can even list, if you want, your variables. Test 1, test 2, test 3. So you can get that detailed in your IPO chart. Add the 5 test grades and divide by 5. So you could say average equals and that. So here in our test table, we're just going to pick numbers that we're going to test. So we're going to test these numbers. And we should see 90.00 because we want to see two numbers after the decimal, and we should see 90% there. And then we'll pick 100. We'll pick just some random numbers. Oops. And then we'll get our calculator out and we'll do the math. And we just want to make sure that what we do comes out. Whatever we code, now I know this is a super simple program, but as they become larger, this becomes necessary. So 65 plus 75, 75, 80. Oh my goodness, I keep messing this up. So my total is 395. I'm going to divide. Doing something. I'm not able to use a calculator apparently properly. Plus equals divided by 5 equals. Okay, so this gave me 79. I want something to give me some numbers after the decimal. So this, interestingly enough, gave me a whole number. So I'm going to do 180. And 33. Okay, so I have 180 plus 75. Plus 76 plus 33. Okay, and then I'm going to divide by 5. And this one gives me 72.8. And I want to see 72.80. And then notice with the percent, I just want to see one number after the decimal and then a percent sign. So I would see 72.8 and then a percent sign like that. So I want to show you with I want to show you how to use the set width and set precision, not the set width, I'm sorry, set precision and the fixed functions so that we can get our output to look like this. So that test table is the one I'm going to use once I'm done writing my program. So here I would ask the user to enter a test grade. Next one. Okay, I'm gonna copy this and I'm gonna do this 5 times, 2, 3, 4, 5. So this is my input. I want to make sure that everything's lined up and that when I ask for input, I do want to make sure that I have spacing in between each of these. So this is for readability purposes. We want to make sure that whoever comes back to maintain this program can easily read it. I want to see this in your programs also. The test grades can, I'm going to make them float because you could possibly on a test grade get a decimal, like you made 95.5, you got half point. So this will be test 1, comma, test 2, test 3, test 4, test 5. So this is where I'm defining my test grades, and I'm also going to define my average. variables, 5 test grades, and their average. Hit input from the user. And then I gotta do my calculations. Calculate the average. So average equals test 1 plus test 2 plus. Now remember, with division, always remember that an integer divided by an integer is always going to be an integer. But our tests are floats, so we're safe here. We don't have to worry about typecasting or anything of that nature. But if our test grades were integers, so let's say that we made these test grades ints, all integers, then we would be dividing integer by integer because a 5 is an integer. And that would give us an integer. That would leave out all those decimal places. It would truncate our number, and that's not what we want. So if that was the case, you could easily put a float here, which is called typecasting, and we could typecast. If these were all integers, we would typecast it into an integer. I mean, into a float. Or if these were all integers, you could put 5.0 here. And then now it would be dividing an integer by a float, and it would give you a floating point number. But again, we don't have to worry about that because all these are floats. So we don't have to put this 0.0 here. And then I'll put the average and average as a percent. So here I'm gonna want to show two numbers after the decimal. So I'm gonna see out average, but I want to see it out in fixed notation, set precision 2. If you're going to use set precision, you have to use fixed. If you use set precision without fixed, it will, it doesn't force out those zeros, and a 2 will just show you 2 total numbers instead of 2 numbers after the decimal. So play with that so you can see the difference. So here we're going to see out average. And you can either do it on this line or you can do it under it. I like to do it under it. Anytime you set your precision here and fix, like from now on, everything will be fixed in a set precision 2. You can change the set precision later, like I'll show you here in a second. So we're going to see out average. So now we're going to have 2 numbers after the decimal. And when we look back at this, we want to say average colon and then the number, or average equals. So let's make it look like that. So we'll say average. And then average. Okay. I'm missing, there's a few things I'm missing. So this right here, it says line 32 is missing a single quote. Hopefully you can see that. So it points to this single quote here. It's missing the one that goes here. A string. Okay, we'll run it again. And then here it says test 12 was not declared in this scope. Did you mean test 2? And yes, I meant test 2. So it's really nice. Tells you what line. It's line 15. So we're going to go up here to line 15. And I just type that. Notice that as I fix one error, I run again, because sometimes when you fix one error, it fixes many errors. Here it says a semicolon is expected before this cout. So it points to where that semicolon needs to be back at line 15, where I just made that change. So make sure you read your errors. Don't get intimidated by the errors. And then here it's telling me that set precision was not declared. To be able to use set precision, I do have to have a special library, and it's called IOmanip, Input Output Manipulator. So it's manipulating my output. IOmanip. Okay, so now I'm going to enter some test grades. And what I'm going to do is I'm going to use my test table to check that it gives me the output that I want. So my first test was all 90s, and that's what I'm going to check to make sure that I get correct output. 90, 90, 90. Okay. That one looks good. Now I'm going to try the one that has the 72.8. So it's 180, 75, 76, 33. It should give me 72.80. So 180, 76, 75, 33. And there's my 72.8. Okay, excellent. Now, next thing I have to print out on the screen or to display on the screen is 72.8 as a percent. And that's going to be fairly simple. Instead of saying set precision 2, I'm going to change it to set precision 1. Cout. And I'll show you that you can put it on the same line. I don't have to do fixed anymore. From now on, everything is fixed. I don't have to change that. And then here, I'm going to output. There's no new line here. So it's going to output right next to the average. So I'm going to put a space, a few spaces, and then I forgot what it should look like. And then it just wants the number. So I'm going to put average, the word average, the variable average. At this point, the variable average is going to show with one number after the decimal because I did set precision. So let's see how it looks like so far. Do my simple one. So it says 90 and then 90. And then it wants that percent sign. So that percent sign is just, I physically have to display a percent. So in my code, I just have to output a string with a percent. Percent. And that's it. And if you didn't want, if you want to set precision 0, you could do that also. Oops. So this time I'm going to try out my other. So 180, 75, 76, and 33. And then it gives me 2 numbers after the decimal and 1 number after the decimal. Okay, so this is your exercise, your teacher-led exercise, and going through and just reviewing a few things, making sure that you understand how to use set precision and fixed, and making sure that you have comments through your program, empty blank spaces like this. And at the very top, you want to make sure that you have your name. That would be the author of the program. For us, we're going to do the class section and the date. Typically, a program will have these 3 things. And then at the top, you will have, oh goodness, I'm typing everything except what I need. So you'll have the person who wrote the program, the date they wrote it, and the description. And then let's say that I came back and I fixed a bug, or I added some new function. I would put modified by and the date that I modified it, and a description of what I did. So let's say that Joe wrote it, and then I came back a year later and I added a new function, then I would put the description of what I added on here. So for you, we're just going to have those, and you're going to have your class and section number. Okay. Just how I have everything indented a little bit there. Just press tab to get there. I have these comments that comment each section. Okay. Please email me if you have any questions. When you turn in this exercise, make sure that you copy the code. You can just copy the code right into here, right here, after your test table. And you can then copy this. You can do a screenshot of the output. So once you fill this part out, copy all this. And also copy, screenshot the output, at least one output. Okay, thank you.